Hello, how are you doing? Today we'll be discussing about binomial theorem expansion. We discussed about the formula, the need for the formula, and we also discussed certain coefficients in the expansion. That is the binomial coefficient, and except that the other constant, which is the factorial of a number. Today we will quickly revise it, and then we'll be doing part of the sum which was left over in the last question because it had taken a considerable amount of time, and I thought that is probably out of the purview of few people sitting at a place and concentrating on a sum of mathematics. If I'm not, do correct me, write a comment and tell me how long you can study mathematics in continuity. Then I'll tell you something which is really interesting and it's worthy of you following it. At this time, we will quickly be looking up this topic which is there in, remember, all the boards, primarily in the International Baccalaureate, in AAHL, further in International GCSE, then in ISC and in CBSE. Normally it is in the syllabus in class 11. However, sometimes it is also picked up in class 12. Quickly, to introduce myself, I am ⁿC₀aⁿ and I'm taking your class to make you more capable in mathematics so that your scare be converted into marks, your fear be converted into freedom, so that I can sculpt you and I, as a mentor, can take you across this river of mathematics, which has a lot of width as well as depth. And I want you to swim securely and to reach the other bank. Whatever that bank depicts, it might be the result in a competitive examination, it might be your board examinations, whatever. I want you to be happy with your marks and also with the knowledge that you have attained. So, with the resolve that you are going to practice this sum once more, let's quickly give this a head start and let me quickly explain to you the basic concepts once more so that if there is anything which was withstanding, that now will be cleared. Okay, so I like you people, because you studied the short as well as also the long, to quickly write down the formula before I write it. For that, you can pause the lecture at this time and then you can match it. Okay, thinking that you people must have actually attempted to write the formula and written it correctly, now is the time to actually check it up. So if you have some x plus a, which is raised to the power n, then children, this is equal to НC0, x, which is raised to the power n minus 0, a raised to the power 0. To this is added the second term, which is НC1, x raised to the power n minus 1, and a raised to the power 1. To this is added the third term, which is НC2, x raised to the power n minus 2, a square. And children, all of this continues up to the last term, which is НCn, x raised to the power n minus n, a raised to the power n. I'm sure all of this has already been learned. So, to quickly tell you people a few interesting facts about this binomial theorem, if you talk about any binomial coefficient, like I told you, it's a natural number. The number of binomial coefficient from the beginning is equal to the number of binomial coefficient from the end. Meaning that if you talk about a binomial theorem expanded, then whatever be the number of the coefficient, for that matter, let's say fourth from the beginning, it will be equal to the fourth from the last. The value of the binomial coefficients will be equal at the specific number of terms from the beginning or from the end of the series. One thing more, if you talk about the sum of the even binomial coefficients, then that's equal to the sum of the odd binomial coefficients. So this is another value addition. So if, say, you talk about НC0 and to that you add НC2, and to that if you add НC4, right, and all of this, let's say, continues up to НC, say n, where n is an element of even natural numbers, then this is further going to be equal to НC1 plus NC3 plus and so on up to NCn minus 1, because we've considered that n is an element of even natural numbers. Okay, so to quickly repeat all of this, here we are discussing binomial theorem when we are discussing about the expansion of a binomial. Now, a binomial is necessarily an algebraic expression which has two terms, and it is raised to a natural number power, and then this is the expansion of it. However, this n can also be from the other number systems which are there in the real number system, and then this will differ. In times to come, I will be discussing when we have infinite terms, when we can accept rational numbers, when we can accept negative rational numbers, and all of those concepts. At this time, an interesting fact that I told you, that if you talk about a specific number of term from the beginning, then its binomial coefficient is equal to that specific number of terms binomial coefficient from the end, right? And another interesting fact that I told you was, if you add up the sum of all the even binomial coefficients and all the odd binomial coefficients with respect to the number which are written at their suffix, then their sums are equal. Right? In times to come, we'll be discussing more about binomial coefficients, where we'll be discussing what actually these come in terms of value. At the moment, we have this question, and again, I'll be giving you people a little time for trial, after which I'll be discussing the sum with you people. So give it a valiant try, think that you can, and I'll tell you that then you will be. Some people probably will take less time. Some people probably will take more time, depending upon your intelligence, depending upon how much time you've given earlier and how much importance you have given to the subject mathematics. But one thing is assured, that you will be able to do mathematics, for that matter, the sum. Okay, now at this time discussing this question, so what we have here is, we now have here the first part done, and we will actually talk about the second part where we could find out the coefficient of x square in this expansion. So now we just focus towards this part of the question, and I will write it here as the question which has to be done, that is coefficient. That means all the numbers which are multiplied with x square in any term. So when we talk about the coefficient of x square, then obviously it is to be in the product of both of these binomials. So we have to expand both of these. You have the formula above. Here, when you solve the question, you have to write for the examiner that same formula. And after that, at this time, I will actually expand it for you. So we'll have here this expanded to be 4C0 2x raised to the power 4 1 upon 3 raised to the power 0, to which is added 4C1 2x raised to the power 3 and 1 upon 3 raised to the power 1. You all know how all of this is coming, because that has been discussed as a formula as well as also as a mnemonic. That is a trick by means of which you can remember this and understand this. So next, children, along with me, try telling this is 4C2 and the first term is 2x, and it's going to be raised to the power, the difference of the numbers in the superfix and the suffix, that becomes 2. And then you have your a, which is 1 upon 3, and it's going to be raised to the power as is the number which is there in the suffix. Now after this, we have the next term, so that then is going to become equal to 4C3. We'll have 2x raised to the power, this will become 1, and then we'll have 1 upon 3, which is raised to the power 3. Further now, we have 4C4, right? And then we have 2x, which is going to be raised to the power 4 minus 4, that is 0. And 1 upon 3, which is going to be raised to the power 4, right? So this is the expansion of the first binomial, and you require to put this in a bracket. Now, I have a question for you. Which are the terms which are of no use for this question? Which are the terms which are of no use for this question? So this is an answer that you can give me in comments, right? And when you give the correct answer, then there'll be an email which will come from my side, right? For that matter, when you write your answer, you can write it in the comment and also write that that's your answer in the email ID, themathematicshelpline@gmail.com, right? And when you write it, then I'll write an email back to you giving you a gift, okay? So next, now after this, children, this gets multiplied with another binomial, which is a simple one, which you know directly. You don't have to write binomial coefficients. So it's going to be a square, that is 3 square. Then we'll have the 2ab term, that is 2 times of a is 3 and b is minus 2 upon x. Now here you will say minus 2ab, or you can say plus 2a times of minus b. That also becomes minus 2ab. Now to that, children, is added the last term, which becomes minus 2 upon 3 whole square. 2 upon x, 2 upon x whole square, right? And now you will close the brace bracket. And now let's quickly choose those terms which are of our need. That means we've got to get to x square. That means when this multiplication happens, and obviously what will happen is this term will get multiplied with this term. This term will get multiplied with this, and then this term will get multiplied with this, and that is going to happen for all of these 5 terms. But as we've just got to find out the coefficient of x square, so we should actually be choosing those terms which will actually have x square in it, right? And only then we'll be able to find out the coefficient, as I will show you just now. So here we say that we are trying to find out the coefficient of x square in this. Now, which are those terms which actually are going to have x square are going to be what? If you talk about this term, which is 2x raised to the power 4, when it gets multiplied with a term which actually has x square in the denominator, then this is going to work. So both of these will form a pair, right? That means when you multiply both of these terms, then you will get x square. Further now, if you talk about this term, when it gets multiplied with one such term which has x in the denominator, then it will give you x square in the numerator. Now, if we talk about the next one, it is directly that one which in itself will form x square. And there is no such term in the second bracket. As such, it requires to be multiplied with the constant. Now, we'll mark this with a hash. So this hash is going to be the mark which, when both multiplied, will give you x square. Now next we talk about the next one. If we talk about this 2x raised to the power 1, it requires to be multiplied with another term in the other bracket where there is x in the numerator. Is that there? No, it's not there. Similarly, if you talk about the next one, the last term is one such which has no power of x, because 2x raised to the power 0 is going to give you 1. And if you talk about the other bracket, there is no term where the power of x is 2. As such, this is going to go for free. We are not going to use this, right? So next step now, we will say that the coefficient of x square, thus, is going to be found out by the sum of these. So what are these? The first now is when you have 4C0, 2x raised to the power 4, and 1 upon 3 raised to the power 0. Don't worry, we'll simplify in the next step, right? Okay, so when this is multiplied with what? When it is multiplied with this term which had a single tick, then we get x squared in the numerator. So we have this multiplied with minus 2 upon x, which is raised to the power 2. To this, children, is going to be added the next term, that is going to be the ones with the double ticks. So which is the one with the double tick? The first is 4c1 2x, which is raised to the power 3, and then further we have 1 upon 3 multiplied with it, right? This, children, is going to be multiplied with the one which has got double tick, that is this one, to give you again x square as the variable's power to be 2, right? So here thus we have this to be further multiplied with 2, which gets multiplied with 3, which further gets multiplied with minus 2 upon x, right? Now after the, children, the next one is what? The next one is the one which has got the hashes, right? So which are the two which have got hashes? So these are the two which have got hashes. First is 4c2, and then we have the first term which is 2x, it is raised to the power 2, and the second term which is 1 upon 3, and its power is also going to be 2. By the rule that we've already discussed, that the power of the first term in the binomial is going to be raised to the number which is the difference of the superfix and the suffix, and the second term is going to be raised to the power the number which is the number there in the suffix, right? So this is what it is, but it has got to be multiplied with this term, that is 3 square, the one which also has hash similarly. So we'll have 3 square also here, and this is another term which is going to give us x square, and that is all. And now is the time to simplify all of this and add them up. So the next step, you do this simple simplification. We've already discussed that the first and the last binomial coefficients are 1, right? So if, say, I try and show it to you, so 4c0 is going to become equal to 4 factorial, which is going to be divided by 4 minus 0 factorial. As such, the numerator and the denominator will get cancelled, and as 0 factorial is equal to 1, as such, all of this becomes equal to 1. Next now, children, what we do is we talk about the numbers which are next. So there's 2 raised to the power 4, which is going to come over here, right, as the first constant. Then we have x raised to the power 4, and we have 1 upon 3 raised to the power 0, and any number raised to the power 0 is 1. As such, it will vanish into thin air because 1 is multiplicative identity. Now it is multiplied with minus 2 upon x whole square. Now minus is just the same as minus 1, and when squared, it will become positive, right? So that is the reason why this is going to be a positive term, right? And plus 1 multiplied within will actually again vanish. So now you'll be left out with 2 square, and further you will also be left out with an x square in the denominator. Now this is how, when we apply the rule of indices, you will get a term with x square here, which we will do in the next step. To do step by step takes a little extra time, but then methodically you've done the sum, you've not made any mistake, your corrections are easy. Teacher who examines, it's easy for that teacher, and further you make no mistake, your answers are precise. So make sure you always do steps, you write the formulae which are being used. The teacher understands that if you apply this formula, that's why you've done this. So next term now, we have here 4c1, and like I already discussed with you, if you talk about 4c1, children, then 4c1 can be understood to be equal to 4 factorial, which is divided by 4 minus 1, that is 3 factorial, multiplied with 1 factorial. 1 factorial obviously is going to be 1, but this can be written as 4, which is multiplied with factorial 3. As such, factorial 3 will get cancelled, and thus what will happen is you will be able to get just 4, right? So next now we'll be writing 4 here for 4c1, and after that we have 2x whole raised to the power 3. So that gives us 2 raised to the power 3, and further also x raised to the power 3. And we also have this 1 upon 3, which is left over in the denominator. And further, we have again 2 into 3. And now there's going to be a minus sign which will come over because there's a minus which is in multiplication with power 1. As such, in place of writing this to be plus, we'll rather write this to be minus. And then further, we have another 2 here. And then we have 1 power of x. And this is going to help us in getting to x squared. Now is the time for the third term. So children, in the third term, what we have is we have 4C2, and that will become equal to 12. I'll show you how. So if you talk about this 4C2, right? So 4C2 is going to become equal to factorial 4, which will be divided by factorial 2, and again it will be multiplied by factorial 2 in the denominator, right? So we have this factorial 2 in the denominator. Now you can see that this factorial 4 can further be written as factorial 4 into 3 into factorial 2, right? So when we write this as 4 into 3 into factorial 2, and when it is divided by factorial 2 again multiplied with factorial 2, both of these factorial 2's are going to get cancelled, right? And then you will have here 4 into 3, which is 12, and then further, as this is 2, so this is going to become equal to 2, right? So I'm sorry, 2 will get cancelled. As such, this is going to become equal to 6, right? So further, we have the third binomial coefficient, which has just thus been calculated to be what? It has been calculated to be 6. So now we talk about writing our third term. So our third term, children, will become equal to what? I'll rather go over a little to the left hand side. So the third term is now added to it 6, which is further multiplied with 2 square and with x square. And then further we have 1 upon 3 square, right? And then further we have this multiplied with the term from the other binomial, that is again 3 square, right? So now we children, we are going to do the simplification, which will give us a lot of gratification, right? Okay, so to simplify, we see here that we have some rules of indices which are applicable, which I'll quickly discuss with you. So if you have some a raised to the power m which gets multiplied with a raised to the power n, what is that equal to? This is the product rule of exponents. Very correctly said, Sir Vijit. That becomes equal to a raised to the power m plus n, right? Similarly, children, we now talk about another rule of indices, that is, if we have some a raised to the power m, and if that is divided by a raised to the power n, then that is the quotient rule of indices or of exponents. What is that equal to? Yes, David? Very good. So that becomes equal to a raised to the power m minus n, right? So now, children, we'll be using these rules to simplify our expressions. So at this time, we will have here, in the next step, the first term, which was 2 raised to the power 4, and we have 2 raised to the power 2. So here, what will happen is we'll have 2 raised to the power 4 plus 2, that will become equal to 6, right? So as such, the first term gives us 2 raised to the power 6. You need not calculate this. These are big numbers that will become, so you can just leave it as it is. What you should be doing is you should be doing the correct procedure with the proper reasoning, proper formulae, and you're sure to get marks. Okay, now after this, what will happen is next you talk about the power of x, which again is going to become equal to what? It will become equal to, okay, one thing more, you can actually show this to the teacher as another step that you've done. So it is 4 plus 2 that you have done, and here if you talk about the power of x in a similar way, it will become 4 minus 2, as the power of x is 4 here, and the power of x in the denominator is 2. So by the quotient rule, we have it to be the power as m minus n, that will become 4 minus 2, right? So that thus becomes your first term. Now we'll come over to the second term. If you see, 4 is just the same as 2 square, right? So we will write this down here. That is, we have 2 square here, children, and then that further gets multiplied with 2 raised to the power 3. So as such, we will add to this 3, right? And now we have one more 2 and another 2. So as such, plus 1 is going to be written here, right? And further, if you see, then the powers of 3 are the same in the numerator and the denominator, and they will get cancelled. So you have 2 plus 3 plus 1, that will become the power of 2, right? And thus that becomes equal to 3 plus 2, 5 plus 1, 6 plus 1, 7. So that's 2 raised to the power 7, right? And further here, if we talk about the power of x, that becomes equal to this power of x as 3, and there's power of x as 1 in the denominator. So that thus becomes equal to 3 minus 1, that becomes equal to 2, right? So we will show the examiner that we have done it correctly, applying the proper formula. So we will write the final answer in the next step, right? So that then becomes equal to 2 raised to the power, x raised to the power 3, and for this minus 1. That is all that we have in the second term. Now we directly come over to the third term, which at the beginning itself we saw is pretty simple because there were a lot of things which were getting cancelled. Okay, so here we get to see that this 3 square and 3 square will get cancelled, and further we have nothing which is going to get cancelled, but it will get multiplied and added. So here we have 3 which is going to be multiplied with 2 raised to the power 2 as it has been given, and further that is all, and thus this is further multiplied with x square, and that thus becomes your last term. Now there's one thing that you can do here, that is first simplify and then take the x square common outside, right? So here we'll have 2 raised to the power 6, then we will have x raised to the power 2, and from that is subtracted 2 raised to the power 7, x raised to the power 2 again, plus we have 3 which is multiplied with 2 raised to the power 2, right? And which is further multiplied with x square. Now, as you see, there is x square in all of these 3 terms. As such, this will help us to get the coefficient of x square. Now, there's another thing that you can see, and that is what actually helps us. If you don't start calculating too soon, you can actually simplify for the last step. Now, here you have 2 square, which is common in all of these 3. So as such, this 2 square can also be taken common outside, and then inside, children, here you'll be left out with 2 raised to the power 4, right? And then here you'll be left out with 2 raised to the power 5, and here you're going to be left out in the third term as just 3, right? Now this number can very easily be calculated, and thus that will help us to get the coefficient. So for the children, this is then going to become equal to x square, which is multiplied with 2 square, that becomes equal to 4, right? And further inside, we will have 2 raised to the power 4 is 16, that is 2 to the 4 to the 8 to the 16. From that is going to be subtracted 2 raised to the power 5, that is 32, and to that is going to be added 3. So 16 plus 3 is 19, and 19 and 13 will make it 32. So as such, you will have minus 13, which will get multiplied with 4, further multiplied with x squared to give you your answer, right? What I said was that if you talk about 32, which is the negative number, and from that, if you subtract 16 plus 3, which is 19, keeping the minus sign with the answer, because 32 has negative sign and it's the largest number, that will give you the coefficient, okay, when multiplied by 4. So 9 and 3 is 12, and then we have 2 and 1 is 3, that is 13, right? This is how we got 13. I got some questionable expressions on your faces. As such, I told you about this simplification. Okay, so as we've got 13 into 4 is 52, right? Okay, so further we have here the final answer to be equal to minus 52x square, and thus, children, finally you can write here that answer is coefficient of x square is minus 52, and you can put that in a box so that that falls in the attention of the teacher and the teacher gives you full marks, right? So all of this I will explain to you again so that if there is any point of time where you are feeling confused, all of that vanishes. Okay, children, so we discussed the initial concept where I told you about the formula, I told you about a special property, and then we came over to the second part of the question which had to be solved. So in order to get to the coefficient of x square, you require to get to all the terms which have x square as we saw just now. For that, the expansion of these binomials are required. The product of the terms is required. But here we will not be multiplying all the terms, but we'll only be multiplying those terms which are going to get to x square, right? Okay, so what we do is we expand the first in accordance with the rule that we've discussed. Then we expand the second one, which is pretty simple, which is a minus b whole square, which becomes equal to a square minus 2ab plus b square. And after that, children, what we do is we now start thinking which are the terms which will give us on multiplication x square. So if you multiply this term, right, with this term, then you will get x squared. That's because you'll have x raised to the power 4 in the numerator and you'll have x raised to the power 2 in the denominator. Similarly, if you talk about the multiplication of this term with this term, then again you will get x raised to the power 2. That's because it will become x cubed upon x type of a term. After that, if you multiply the term which has x square here and is a constant term in the second bracket, so the multiplication of both of these again is going to give you the coefficient of x square, right? So if you talk about the rest of the terms, they are not of any use, right? So we will rather dispatch all of these as not useful. So we pick up all of these three terms, right? And then that is the ones which are single ticked, the ones which are double ticked, and the ones which are with hash. Okay, so we put them up, and then is the task of simplification. In the simplification, the only complicated thing is the binomial coefficient. You very well know that if we want to find out the value of a binomial coefficient, then any НCR will become equal to factorial n, which is divided by n minus r factorial, which is further multiplied in the denominator by factorial r, right? So when we do this, children, then we will be able to get to the binomial coefficients, and that further is going to be multiplied by all of these numbers that these terms have. And taking x square outside, multiplying all the numbers, this number along with the sign is, that is either plus sign or minus sign, is going to give us the coefficient or the number multiplied with the term which contains x square, right? Okay, so now we apply this rule and simplify all of these binomial coefficients, and whatever gets cancelled is the same in the numerator and in the denominator, or probably some powers, we cancel that off, and further we actually apply these rules, and thus we are able to simplify. And after this, next what we do is we find that all the terms actually have x square. So we take this x square common outside and accept that all the other numbers also which are common in all of these three terms are taken outside for easier calculation. Further, when we solve all of these numbers which are within, right, we get to a number which comes to minus 13. Now, multiplication with 4 will give us minus 52 times of x square. Now the coefficient or the number which is multiplied with x square is minus 52. So this then will become our final answer, that is coefficient of the term which contains x square is minus 52. Always write the final answer with a different colored ink. Don't use any shade of red, right, or green, because green is for the principal and red is for the teachers. Okay, so you can use, say, light blue, you can use dark blue, you can use black, right, or you can use some of the shades which are possible, right, which are not of these two colors, red and green, and you can finally write your answers, especially the numerical part, the number, in a box which helps the teacher to realize that this is the answer. So I hope all of you people must have been able to understand this and must be feeling confident in such sort of sums. But don't you require clarity in sums which are of other type, which are there in this chapter, because this is a big long chapter, right? So for that, children, there is a form which is there in the description or in the first comment. Just click on it, tell me what your problem is. I will be there, amidst you, one-to-one, holding a session where whatever your problem is, I'll tell you the roadmap, I'll help you out, and I'll take you across the river of mathematics with ease. I'll vouch, guarantee, promise that you will come out of my mathematics mentoring to be one such child who now tackles mathematics sums as if you're just having bread and butter, right? So do give me the opportunity to serve you. And like I told you, I'm going to make you a specialist. So good that you'll be known as a mathematics ambassador. So bye, children. Have a nice time. And do make sure to get that help when you require it. I'm always there standing for you. Bye.